Okay, so we're going to do the cross product, U cross V, just the general formula, come up with it, general way of doing it, with U, V, U1, U2, U3, V1, V2, V3 for vector V. Nice way of doing it is kind of a different swing on the determinant method, IJK. So we make that matrix determinant made up of IJK, U1, U2, U3, V1, V2, V3. To do this nice and smoothly, to account for everything, we're going to include the first column a second time, I, U1, V1, and then J, U2, V2. Now it's a matter of doing diagonals. So all the diagonals this way are going to get added. So we'll start with the first one. I'll just do U2 in order. So U's first, V second, U2, V3, and that's an I. The next one, add U3, V1, and that'll be a J vector. And then the third one I'll add on that side, U1, V2, the K vector. Anything going the other diagonal, we'll just do them as we see them. We subtract them. So the first one is going to be, and I'm going to do this again in order of U, so U2, V1. And then I'm going to subtract the next one, and that is actually a K, should say. The next one is going to be minus U3, V2, I. And then the last one is going to be minus U1, V3, J. That comes right here. So when we do this, put them all together, we have the two I's. So I'll do this in I, J, K format sort of thing. So the first set, the I's will be U2, V3 minus U3, V2. Okay. The middle part, the J, will be, I'll do the positive one first, U3, V1J minus U1, V3, J component, and the K's, I'll do the positive one first again, U1, V2 minus U2, V1. So what we get essentially is a nice formula where if we have that vector, we end up with this as the cross product. That is one way actually to memorize it, or simply to do it in this method. So to do this in a method with some numbers, so I will use the numbers 1, 2, 3 for vector U, and just 4, minus 1, 2 for vector V. So here's my U, here's my V. So I'll set that up again the same way. I, J, K. Put my first vector in, 1, 2, 3. My second vector, 4, minus 1, 2. Repeat my two columns. I, J. Now it's a matter of doing diagonals again. So along this diagonal, I add is going to be 2 times 2 is 4I. Along this diagonal, I add 3 times 4, 12J. A little easier with numbers. And this last column, I'll have 1 and minus 1, minus 1K. So what I do is I go along these diagonals and I add the numbers. Got a minus 1 this last one because it was 1 times minus 1K. Going the other way, it gets messy here. Take some of that mess away. On the other side, it would be 4 times 2, 8. Now because it's on the left, negative 8. K, follow what that's saying. The next left diagonal is going to be minus 1 times 3, minus 3 with the minus sign, that's plus 3. So it's negative 1, negative 1 times 3 is negative 3 times the negative is 3, and that is an I. And then the final one is going to be 2 times 1 is 2, 2 minus 2j. So collecting, I'll have 3i and 4i. That will be 7 for the first component, 7i. Cross them out, I took care of them. The j, I have 12j and minus 2j. That's going to be 10j. And then I have minus 1 and minus 8, negative 9k. And that's basically how we do our cross product. We can check the cross product. What we've got, remember, with the cross product is the third vector, this vector W. Quiet, girls. So this vector W is orthogonal to the first two vectors because that's what a cross product means. Remember, we got the two first vectors, U, the vector V. So we've computed a vector that is orthogonal to the first two. That's what the whole cross product is doing. So what we have is we had the vector 1, 2, 3. We had the vector 4, minus 1, 2. And now we have the third vector, which is 7, 10, negative 9. So if we just randomly took the cross product, or the dot product, I should say, of any of these two vectors, so if I dotted 1, 2, 3, and I took the dot product with that of 7, 10, minus 9, what would I get? The dot product would be 1 times 7 plus 2 times 10 plus 3 times negative 9. And if you notice, that'll be 7, 27 here minus 27 there. So I get the dot product of 0. Not surprising, these vectors are orthogonal. If I was to randomly choose 4, minus 1, 2, and I dotted that into 7, 10, minus 9 again, the dot product should be 0. So 4 times 7 plus negative 1 times 10 plus 2 times negative 9. So I'll get 28 here, I'll get negative 10 here, negative 18 there, and again, I get 0. So I check that U dot W is 0 and that V dot W is 0. So indeed, W is orthogonal to U and W is orthogonal to V. That's exactly what we wanted to find.